Hello everyone, welcome to the session of Class 6 Mathematics, and I am your Anu from MathSchool.1. We have been seeing the chapter 4 Basic Geometrical Ideas, and I have told you about the points, the importance of point and the lines and types of lines, line segments, lines, rays, and even perpendicular lines and intersecting lines, parallel lines, isn't it? So now we'll continue with our geometrical ideas still further. Okay, so today we'll be seeing more about lines and rays. See, when 2 points are given, when there are 2 points, we can draw a line on it, isn't it? With it we can draw a line. Only one line can be drawn with 2 points. Whereas if 1 point is given, how many lines you can draw? You can draw infinitely many lines passing through it, isn't it? See, infinitely many lines. We won't be able to count it. Infinitely many lines can be drawn passing through the point. And these lines which pass through the same point are called intersecting lines, isn't it? They intersect at a common point, so they are called intersecting lines, isn't it? So now I've also told you, see, when there are 3 points in the same line, see, when there are 3 points in the same line, we call these 3 points as collinear points. What do you mean by collinear? Collinear, that is, they all exist on the same line. So with these 3 points being collinear, we won't be able to draw any other than the line. Only a single line can be drawn through, which passes through all these 3 points. Okay, so if it is collinear, if the points are non-collinear, for example, if they are not collinear, that is, they don't lie on the same line, that is, they lie somewhere else. Okay, if they are non-collinear points, then we'll be able to draw a shape with that. Say for example, we can draw a triangle with 3 points. Okay, that thing, actually that is the point you should remember. Non-collinear, only with non-collinear points, 3 or more than that, non-collinear points, it will be, we'll be able to draw a shape. Okay, if they are collinear, then we won't be able to draw any shape than just a line. Do you understand? So those are called collinear points which lie on the same line, and with non-collinear points we will be able to draw a shape. Okay, so now we have seen intersecting lines, and we have also seen parallel lines. I said, what are parallel lines? Parallel lines are 2 lines, set of lines which pass along each other, but they don't meet at any point. Okay, they don't have a meeting point, but they travel along each other such that the distance between them is constant throughout their path. So example for such parallel lines can be the edges of a table. See, the edges of the table are examples for parallel lines, or railway tracks, isn't it? Railway tracks, they don't join, they don't meet at any point, they go throughout maintaining the same distance between them, isn't it? So those are the examples of parallel lines. Now the other kind of lines we have seen are the perpendicular lines, which is the vertical line meets the horizontal line at a particular point, say name it as O. So this type of lines which have 90 degrees between them, they are perpendicular to each other. So perpendicular lines, for example, we see perpendicular lines in flat post. See, flat post, the flat post is perpendicular to the ground. Okay, do you understand? So just like these are some of the types of lines we have seen before. Now the next thing about lines I would like to say here is, when I draw a line AB, see some 3 centimeters, not up to scale, some 3 centimeters, and I draw another line maybe some 8 centimeters or so, and just another line which is 2 centimeters. So these are just line segments, and these are of a kind, that is, they are all line segments, and we say that each line is similar to each other. Every line is similar to each other. They are similar, isn't it? They are line segments. The only thing, the difference among all these 3 lines is the length varies, isn't it? So the length of the line varies. But when I draw a line AB is equal to 3 centimeters and CD is equal to 3 centimeters and EF is equal to 3 centimeters, I say all the 3 lines, see, all the 3 lines have same length, isn't it? These 3 lines have same length. So these kind of lines which are of equal length and of similar type, that is, they are all line segments, isn't it? They are called concurrent lines. Okay, they have the same length. Do you understand? So these are concurrent lines, that is, AB just represents CD and EF represents AB. Just the name differs, isn't it? But the lines are one and the same. So they are called concurrent lines. Either you call it as AB or CD or EF. The 3 lines are the same, are one and the same. Okay, so those lines are called concurrent lines. Now you have understood what are concurrent lines, isn't it? So now the next thing I would like to say is, you know what is a ray. A ray is a line which has an origin, which has a starting point, and it goes endlessly on the other side. That is why it is denoted as, see, if I write A, B some point on the ray, I say AB is a ray and AC is a ray. Okay, you know. So whenever I draw 2 rays with a common point, with a common origin, I see an inclination. See, there is a line here, and there is a ray here, and there is also another ray here, and this ray is inclined. See, this is like this, and this ray is inclined to this angle, to this ray. So this inclination is what we call angle. So an angle is formed with its arms. See, the arms of the angles form rays. Okay, so an angle is formed here. Just like this, see, if you take a cubical box, and if you imagine the lid to be like this, okay, it is open. See, it is open. It is open somewhat to some extent, not fully. So you take the edge of this lid and edge of the box. So this resembles the corner of ray, 2 rays. So this is the common point, and there is an angle formed between the edge of the box and edge of the lid. So that is what we call the angle, and this is the measure of inclination. This is how much it is inclined. See, from this line, I draw this line, this ray, this is a ray and that is a ray, and this is what we call the angle or the measure of inclination, how much it is inclined with respect to the baseline. Okay, now you understand how angles are formed? Yes. So one way of utilizing the concept of rays is making an angle. Okay, so now after knowing about the points, lines, line segments, rays, types of lines, parallel lines, intersecting lines, perpendicular lines, and rays and angle formed by it, we'll move on to shapes. Now shapes are just formed by what is called curves. What is a curve? Now curve is, you can draw any figure like this or like this, or it can be like this, or it can also be like this, isn't it? A curve, generally a curve, it is a formation of some figure or shape, or it's just a line going through some path We can also define it like that. So it's a curve. But what has to be understood here is we have different types of curves and each curve has its own property. Okay, so that is, you just see this curve. I have drawn it by freehand, isn't it? I have not used any scale, so it is not made up of line segments. One thing you should see here is it is not made up of line segments. So this is called a simple closed curve. What do you mean by closed curve? As the name suggests, the curve is closed. So there is no open end here. So what is this curve called? Naturally, this is an open curve. And this is also a simple curve, open curve. So what do you mean by simple? Now you know what is open and what is closed curve. What do you mean by simple curves? See, simple curves are those. These are simple curves. But this is not like this. This is drawn entirely with line segments. Okay. And this is also a simple curve. Okay. But these two are not. These are closed curves. Of course, they are closed curves because they don't have any open end. So they are closed curves, but they are not simple curves. Why they are not called simple curves? Because this type of curves have lines which cut each other. See, they cross each other. See, this line crosses this line and this line, isn't it? They cross each other. Likewise, this also, the line crosses one another. So that is why they are not called simple curves. They are just closed curves, but they are not simple closed curves. Now, do you understand about curves? Now, let me explain the points in shapes. So let us take a simple curve or triangle. I plot a point A here and B, C, D here and another point E here. Now, where is A and where is E and where are D, B and C in this shape? A is inside the triangle, isn't it? That is obvious, we know. A is inside the triangle, E is outside the triangle, and A and B, D, C are on the triangle. Okay, so that means we have regions in shapes or curves. Regions, they are called regions. That is the space occupied by the curve. The inside portion of the curve is called the interior region, and the outer space of the curve is known as the exterior region, and the line which defines the shape, isn't it? Only by this line B, D, C we come to know that it's a triangle, isn't it? The line which defines the shape is known as the boundary of the shape. Okay, so these three are regions you need to know so that we can identify the point where it lies and what is it named. So A lies in the interior region, E lies in the exterior region, and B, D, C on the boundary, isn't it? So on the boundary of the shape. Okay, now do you understand? This is for a closed curve. And what about an open curve like this? Even in the open curve, you have, to some extent, you have interior region. See, A is in the interior region and E is in the, certainly it is in the outer region, and B, somewhere C and D are on the boundary of the curve. Okay, so but what is the difference between this curve, open curve, and the closed curve? Here we have definite region. It is described here. There are limits for interior region and exterior, not for exterior region, boundary. But here there is no certain demarcation between the exterior and the interior. At one point, at one particular, like this, at this point, exterior and interior gets overlapped here. So that is the difference between an open curve and closed curve and the regions of them. Do you understand? So there are two regions, exterior and interior, gets overlapped at some particular point here. Okay, because there is no particular definition in that side. There is no particular boundary for the curve that side. Do you understand? So these are the regions I would like to tell you about any particular shape or curve. Now, after learning about the curves, now let us move on to what we call polygons. Now, what are polygons? We have been saying, until now I have been saying shapes or curves, isn't it? But we give a general name called polygon to shapes. Okay, so what are polygons? Polygons are curves which are drawn using line segments. They are formed only with straight lines. So obviously circle doesn't come under polygon, isn't it? Because circle is not formed by line segments. Okay, so polygons are those curves which are formed only by straight lines or line segments. Now we'll see one by one. With 3 line segments, we can draw a triangle. With 4 line segments, we can draw a quadrilateral. What is meant by quad? It is 4. So quadrilateral. And with the 5 sides, I can draw a pentagon. And with 6 sides, I can draw a hexagon. And 7 sides, if it is 7, then I can draw a heptagon. And with 8 sides, it's an octagon. And with 9 sides, this is 9 side, this is nonagon, and decagon with 6 sides, 3, 4, 5, 6, 7, 8, 9, 10. Okay. sorry. So 10 sides, it is decagon. Okay. So for 3 sides it's triangle, 4 sides quadrilateral, 5 sides pentagon, 6 sides hexagon, 7 sides heptagon, 8 sides octagon, 9 sides nonagon, and 10 sides decagon. And above that it is called generally a polygon. Okay. More than that, it is generally called a polygon. Now, when we see triangle, just take a triangle, the basic polygon. I name the corners as A, B, C. So what are the corners called? The corners, that is meeting point of 2 line segments, AB, BC and AC are line segments. I told you before, lines are to be denoted by 2 letters, isn't it? So these are the line segments or the sides of the triangle, and the points are just denoted by single letters. These corners are called vertex. I mean, 1 corner is called vertex and 3 corners, plural, is vertices. Okay, they are called vertices. So if there are 3 vertices, there will be 3 sides, and hence it's a triangle. So you should always keep in mind polygons have equal number of vertices and sides. So how many sides you have, that much number of vertices you have. How many vertices you have, that much number of sides you have. Okay, so that you should remember. And now in quadrilaterals, so these are generally polygons. In quadrilaterals, we have special type of quadrilaterals, 4 sides, and you know obviously when all the sides are equal, it's a square. When opposite sides are equal, it's called a rectangle. When the rectangle is tilted to some angle, then it is called a parallelogram. See, it's just like a rectangle, but it's tilted. See, it's tilted to some angle, isn't it? So that is a parallelogram. And when you have a square tilted, all the sides are equal and it is tilted a little, it is called a rhombus. And when you have a pair of parallel lines, see, these 2 are parallel lines, 1 and 2. The first side and the second side, opposite sides to be parallel. 1 pair of opposite sides should be parallel. then that is called a trapezium. And the last one is the kite formation. This is the kite shape. This is just like kite, and we see the opposite, one set of, not this, adjacent, one pair of adjacent sides are equal. The adjacent pairs are equal. So that forms a kite shape. Okay, so these are the special types of quadrilaterals we should know about. And we will see each and every shape in detail in coming chapters in in geometry. You will be seeing each and every shape or each and every quadrilateral in detail, and we will also see the properties of each and every quadrilateral. So the thing you should remember in any shape is the general or the basic components of any polygon is, I denote the vertices by single letters and sides by two letters, A, B, B, C, C, D and D, A. There are some line segments which don't form the sides of the polygon. They don't form the sides of the polygon, and they have opposite vertices as their endpoints. See, A's opposite vertex is C and B's opposite vertex is D. So when I join BD and AC, they don't form the sides of the polygon and they have endpoints as opposite vertices. These lines are called diagonals. Okay, just remember the name. These are called diagonals. And when I say AB and BC, they are called adjacent sides because they are next to each other. So they are called adjacent sides. When I say AB and CD, they are called opposite sides because they are opposite to each other. Isn't it? Likewise, if I say angles, see angles in each corner, A and B are adjacent angles, B and C are adjacent, C and D are adjacent, B and A are adjacent. But A and C are opposite angles, B and D are opposite angles. Okay, so now we have understood adjacent sides, opposite sides, diagonals, adjacent angles, opposite angles, and opposite vertices and adjacent vertices. So these are the some basic terms you should know in any particular polygon. Okay, so these are some of the terms we have seen, and particularly the diagonals, which doesn't form the sides of the polygon. Okay, so up to this, I stop with this class, I end this class, and in the next class we'll still see about quadrilaterals, that is special type of quadrilateral. Each and every special type of quadrilaterals we'll see in detail, and also about triangles, types of triangles, and also about the circles, which is also a curve, a special kind of curve, isn't it, which is not made up of line segments. So we'll go through all the other things in the next class. So until then, it's bye from Anu from mathschool.1. Thank you.